Okay, so we thought it would be fun to have a 7 secrets of IBM SPSS Modeler video. Now, if you're extremely familiar with the software, or if you've been on the formal training, you may not regard these as secrets per se, but certainly if you've ever downloaded to evaluate the software, or if you're self-taught, there's probably a whole bunch of functions and cool features in there that you're not familiar with. And we thought it would be a good idea to draw attention to them. The first one we're going to look at today is the Data Audit Node, which we're billing as the Swiss Army knife of data cleaning. So let's have a look at it. So the Data Audit Node is this little square node which, as the name implies, audits the data. It gives us an overview of the data. When we run that downstream of a source node, it gives us an overview of the data, both in terms of little charts that it produces, little graphics, and also in terms of the minimum, maximum, and some summary statistics here. It also tells us the number of valid cases there are, so it's taking out any null values there, and it also gives a little report on unique categories within the categorical fields. So the categorical fields here have two categories. These are flag fields, and this is actually quite useful for when you've got a lot of data and you've read it in from a database, for example. You often get, believe it or not, data where you only have one value in a lot of the fields, and you really want to get rid of those. So sorting them in order and just getting rid of them is an easy thing to do from here. People don't know that it isn't just that categorical or that the dichotomous flag fields like this can be used to color the charts. If I change the target here to a continuous field, I make that target field, then it changes immediately, takes account of that, and it turns them all into scatter plots. So it's showing every field in relation to this key target field here, which is shown a third one down. Okay, if we go back there and just swap that back to response, let's point out a couple of extra little functions and features here that people don't know about. In the background, we've got a little tab here called quality. If we look in quality here, it gives us a sort of quality report and a number of things we can do to deal with unusual cases or non-legitimate cases. So here we have, for example, a report indicating outliers and extremes. These are settings that you can overrule, so you can create your own outlier and extreme thresholds within the Data Audit Node. But more importantly, there are actions that you can take against them. So I can go to action here and say, well, let's get rid of outliers and extremes. So I can coerce them. That means it forces them into a legitimate value. I can discard those records, so I can get rid of them. I can nullify them. I can treat them separately, so I can force outliers to be legitimate but discard extremes, or force outliers to be legitimate and nullify extremes. If I just went for discard here, I could click on that and say, okay, go and generate for that particular field there and say outlier extreme, just selected fields only, and click OK, and it will go and create a little super node for me, and everything downstream of that. That means that all of those records that had outliers or extremes in that particular field will be discarded. So there'll actually be fewer records. Let's check that. So that's 5,494 versus the original record count of, let's have a little look here, of 5,837. So we can see that's having an effect. What else can we do here? Well, there's other things with regard to missing data. So you can see here in missing data, we've got a little report here on missing data. It's telling us what percentage were complete, how many valid records there are, what type of missing data we have here. All the missing data is in the form of null values. It could be blanks within strings, or it could be user missing values, special codes that you've given the system to indicate that data is missing. But again, here within the missing columns here, we have impute missing. So I could take, let's say, here we've got some missing data here in this one here, and I could say, well, impute missing, I could say for just blank values do something, or null values do something, or blank and null values do something. So I say blank or null values, I want to specify a value. So I can say, okay, I want to put enforce in the mid-range, or put in the mean, or put in a constant value and say I want a constant value of 45. So there's different methods I can use, or I can say for blank null values I want to just choose a random value, or I can go into an expression here and say I want to set up an expression and say, if they're female aged over 35, then the value should be X, and if they're male aged over 35, the value should be Y, etc., etc. Or I can even use an algorithm, which in this case is CNRT tree, which will attempt to actually predict the value of the missing data there. So that's quite powerful, and people don't really know about that. So there's other things you can do with missing. We can say put in conditions here. We can come up with conditions and when the algorithm is fired. There's tons of different procedures here, and again, all of that is used through the generate menu if you wanted to create a little node which will impute the missing values, and that's the next thing we're going to look at. Okay, so now we're going to have a look at the second item, which is the generate menu. This is the super quick way to create new fields. Okay, so now we're going to focus in on the generate menu. You've seen me use that already in the Data Audit Node, but it's actually got lots of different features and functions which are really useful, and we don't think people pay enough attention to it. So let's look at some examples of where we can use it here. First example we're going to look at is where we can use the generate menu to very quickly define data filtering and select subsets of data. So here we have some rows of data, 6,192 of them. Each row represents a customer of an IT wholesaler. You can see here that we have fields indicating the sector that the customer belongs to and whether or not they have a support contract. So let's say we're interested in filtering out those who have a support contract and who belong to a particular sector. Let's go for telco and media. So we'll click on that. And if I go to generate up here and go select node and, it will generate a select node based on an and condition. So they have to belong to both of those groups. And we can see inside here it's creating the syntax for us to do that, where sector equals telco and media and support contract equals T for true. And if we just want to check that's worked, downstream of that, run the table, and we can see that everybody in the 26 records it's found that meet that condition have support contracts, and they all belong to the telco and media sector. So it's a really simple way in which we can use the generate menu. It's really fast. It's a lot quicker than typing in the syntax. Next section we're going to look at how we use the generate menu to work with charts. So let's have a little look at a histogram here. Here's a histogram of revenue per cell, and I can split this into different groups and get it to generate a node which will break these into groupings and bin them if you like, or I can manually interact with it and just right click on these and select it, and I can rename the bandings here. So I can rename this band. It's going to call it band 1, band 2, band 3. So you can see I can call them low, medium, high. But I'm not going to bother at this stage. Let me just go to generate here, and I can go to generate derive node for bands. It creates that for me, and here we have this new field that's been created here. If we look inside here, it's just calling it band, and it calls it band 1, band 2, band 3. So we can just connect up to connect it to a little distribution node here, and look at band. Maybe hit run, and here we have band 1, band 2, band 3. It's just basically created those 3 groups for us. Okay, what about actually collapsing groups together? Let's have a look at what we had here before, and we had sector. Hit run. So here we have, as you can see, it's fairly uneven in terms of the sectors that's produced. We've got different count here. I could, for example, just say select the bottom 3, and I could group them together and rename that group, edit that group and rename it. We'll call it MIS for miscellaneous. Click OK. It's a very quick way in which we want to collapse groups together. And then again, go to generate menu and go to generate reclassify node groups. Click X to close that down. And then let's just right click. I'll put sector on the end of that. I can either get it to overwrite the existing field by right clicking in here and say existing field, and we run that again. We can see that now we've got a category here called MIS miscellaneous 616 records. So again, using the generate menu to very quickly group things together. What about creating flag fields, indicators that maybe point out unusual relationships or anomalous relationships? Well, if I just show you here, I've got a little scatter plot here, and the scatter plot is showing me the relationship between total revenue and level of contact. We've got some anomalous cases here. I mean, I could go in here and interact with this data and say, yeah, I'm kind of interested in maybe just drawing a box around these cases here. Let's just say that they're unusual, they're anomalous. If I go to generate up here and go to derive node for marked elements, it will generate a derived node for me. And if I look inside that, a derived node is basically made up of trues or falses. If they fall within that group, they're true, and if they don't, they're false. So it creates a little indicator field for me. So I could rename this to anomaly, and it would create this little marker field for me. A very quick way to do that. And finally, what about looking at balancing our data? You've seen when you've got uneven data here. Let's say that we've got a target field and we want to make it 50-50. We want to rebalance the data so that we have 50% of the cases fall into the 0 group and 50% fall within the 1 group here. And this is the proportion of people who have purchased within the mobile group. For whatever reason, let's say we need to rebalance the data. Again, if I go to generate here, you can see you can balance node reduce, which will reduce it down, artificially reduce it down to 1500 cases roughly each, or boost it, will artificially boost it up to 4600 cases each. Let's go for balance node reduce, and that will rebalance the data for me downstream of that point, and we'll just put a copy of mobile on the end of that. This is all through the generate menu, remember. Hit run. And now we have roughly 50-50 each, so it's rebalanced the data, it's weighted the data so that we have equal proportions within that grouping. So that's the generate menu there. A bunch of different procedures are very, very useful and real time saving benefits associated with that menu. Sometimes the issues of the data aren't related so much to the values within the data, but more related to the field names itself, or the presence of unneeded fields. And the filter node's really useful at that, and it's got a bunch of tricks to dealing with awkward fields, so we're going to have a look at that. Okay, so now we're going to look at a couple of tips and tricks associated with this little node here called the filter node. The filter node is a node within the field ops tab. It's also something that you can call up, the functionality you can call up within the source nodes themselves. So you can see we've got a little filter tab here just to save you the trouble. I'm going to explicitly connect it to this data set here called awkward field names, and just zoom in so you get a better look at it. And if I look inside here, we can see what it's doing. It's reading the fields, and it's giving us the opportunity to either to exclude that field or to rename it. So we can actually rename it and get rid of it and give it a different name, so that it's a legitimate name. However, that's quite difficult to do when you've got lots and lots of fields. It may not really be a good solution. We're noticing here for this first field, we've got spaces between the characters, region of country. And although that's not a problem for Modeler, it can cause problems further downstream for certain routines, and it can particularly cause problems when you're dealing with third-party applications. So it's a common convention is to replace the spaces within field names with something like, for example, an underscore. Other awkward field names are things which have non-legitimate values like percentages or asterisks, or field names perhaps that begin with a number, or field names which are really too long. So these are all common issues, and the filter node has got a couple of tricks up its sleeve that help us deal with that. If I right click on this little drop down button here, we've got filter options menu. It may be, for example, that you're reading loads and loads of data in here and you only need 10 out of 1,000 fields, so removing all fields is a good way to switch off all fields and just cherry pick the 10 you want to include. And so it allows us to toggle back and forth between remove and include all fields. Then we can rename duplicates. We don't have any duplicates here, or remove duplicates. Rename for IBM SPSS statistics is a really useful function, even though you may not be using SPSS statistics, because when I click on that, it says, okay, I'm going to replace invalid characters with a hash or an underscore. And if I click on that, you'll see that region of country now is replaced by region underscore of underscore country. It's a really useful thing to have. And here we have tenure percentage is replaced with an underscore, and 3 age is replaced with x3 age. So it's just done that. It's just made it a legitimate value, a legitimate name. It's much easier for us to deal with. Even address space parentheses 1 here has been replaced with underscores. Again, that may make things a lot easier. We can also use things like truncate field names. So we've got really long field names, we can say no, the maximum length needs to be, I don't know, 18 or something like that. And you can see that this marital status at last known address has been truncated at that point down to 18, which is a nice sort of way to deal with those sorts of things. We can anonymize the field names. Let's say we're going to send them to somebody else. and so on and so on. So this is kind of a useful little procedure that people perhaps don't know about or don't use very often, but it's a real time saver. It's a really good way to deal with awkward field names. There are other things that the filter node becomes important with. So for example here, if I'm building a model, here I'm going to build a model, I'm going to predict an outcome, and I just want to show you the number of fields that we've got here. It's a different data set, but you can see we've got 42 different fields here. The model itself may not use all these fields, and indeed 42 fields isn't very many really for a lot of data sets. You might have hundreds and hundreds of fields, and again it can be very difficult when you're working with the fields which are important to you. So if I right click here and run the C5 model, it goes and creates a little model for me, and if I look inside the model, it doesn't use all of the fields. You can see it's using a subset of fields here. This is the number of fields. If I go to generate again, which you saw earlier on, I can say filter node inputs not used, or filter node based on predictor importance. The top 10 fields are importance greater than a certain value. So if I just go generate filter node inputs not used and click OK, again a filter node is created for me, and it filters out all of the fields which it hasn't used in that model. So if I'm working on that data downstream, I maybe want to use C5 as a type of predictor selection tool for me, and working in conjunction with the filter node makes that a very useful and very compelling procedure. So the fourth secret is the Graphboard node. Again, it's a single node in and of itself. We think it's really useful. It's a real visualization goldmine, and we think most people probably don't pay as much attention to it as they should. So people who use Modeler may well be familiar with standard plots and charts that you get along the bottom here: distribution charts, histograms, plots, etc., etc. But not many pay a lot of attention to the Graphboard procedure. If I connect the Graphboard procedure up here, one of the things that makes it really useful is that it recommends charts to you. So if I click in here, you can see I've got some data here to work with. If I click on a single field, it says, well, a single continuous field like that, you can have a histogram or dot plot. If I check another field, it says, okay, you can have suddenly lots of different options. You can have area plots, you can have ribbon plots, you can have bin scatter plots. If I keep on selecting these continuous fields, I can get down to parallel plots or scatter plot matrices, which is quite a nice way to visualize and show lots of different charts together in one place. So it's a bit like a correlation matrix. Not many people tend to use it very often. So here we have the relationship between things like engine displacement and horsepower, or vehicle weight here and horsepower, or not a strong relationship, as you can see here, between time to accelerate and vehicle weight, etc., etc. So it's quite a useful way. So there's a whole bunch of different charts in there people really don't pay a lot of attention to. I mean, if we just show you a bunch of other ones here that we've got things like, some nice clustered box plots here showing the relationship between miles per gallon over each year of a car's manufacture, broken down by whether or not it's American, European, or Japanese in origin. Similar sort of thing here. We've got a heat map, very useful for when you've got lots of categories in a categorical field, and you want to show the relationship between two categories in categorical field and fill them with, let's say, the mean value of a continuous field. Here it is horsepower. The highest horsepower is American cars in 1970 versus European cars in 1982, where the horsepower on average is about 63, and so on and so on. So we use lots and lots of different charts. Here we have, for example, a paneled bubble chart here, miles per gallon. It represents the bubble sizes, but it's actually the relationship between engine and horsepower, again broken down by 3 different regions. And even things like 3-dimensional charts, where we can see the relationship here between weight and MPG. It's very easy to just interact with it and zoom into it. And we can even animate it here. We've got an animated chart where we can say, okay, well, let's show me how cars are getting lighter and are more fuel efficient over time. We can step through the animation, or we can just have it cycle through it very quickly for us as it shows us cars getting lighter and more fuel efficient over time. So So number 5 on our list takes us to the simulation nodes. And they're useful in lots of different ways, but they're particularly useful for things like what-if analysis. Let's take a look at them now. So the first simulation node that we encounter is the simulation generation node. And we find that in the source nodes here. So it's just one of these circular nodes. And it's really useful because it allows us to create simulated data. But it allows us to do it in a very particular way. You notice here I've created some fields already. If I hit preview, you can see the simulated data that's been created here. This is just the first 10 records that's been shown. And we have things like the distribution properties, which we can add in ourselves. We can set the minimum, maximum, and tell it whether it's an integer, a real number, or even string if we wanted. If I wanted to add in another field here, let's pretend it's something like a test score that these people have taken. So let's just change that to the field test score. And I can go in here and say, well, let's give it some distribution properties, and I could choose a particular distribution. So I could say, okay, let's go for a normal distribution. I'll give them a mean of 62 and a standard deviation of 18, and I'll even specify a minimum maximum. Notice it immediately creates a distribution for us here, so we can say reject values below 0 and a maximum of 100. Click OK. Now we hit preview and we have these test scores which are being shown here. Again, we might want to change these to integers, so just turn them into integer values, and we can even control the correlation between this field and other fields. I've already created some correlations here already, but for example, let's say I wanted to say there's a strong correlation between age and people's test scores. I could click in here and say, okay, well, there's a correlation of 0.55 there, and it immediately creates this correlation between age and test score. And I could say this test score between spend and there's a correlation between test score and spend, so it says 0.32, and hit OK. And then advanced options tells us how many cases we can create, etc., etc. It's really powerful. Hit types here, it'll now create this data set for us just as if it's in an ordinary data set, and we can connect that up to a table. And there we go, and it goes and creates an ordinary data set for us of 100,000 simulated records. Now that's quite useful. There's another way we can use the simulation nodes. There's another simulation node that we can work with. If we go down here to the output, we have something called the SimFit procedure. So here I've already got some data. This is sales data, and if I hit run here, it runs the sales data. Here's some data that we've got, referring to advertising spend and consumer confidence index and the number of agents available in a store, traffic values and sales of a store. And if I wanted to actually simulate that data, I could use the SimFit procedure here, which I can connect up to it, and I just run it, and it creates for me a little SimGen node just like we saw earlier on, but it's completely simulated data. So it's very useful if you needed to send somebody some data, if you got some issue, you wanted them to play around or something, but you wanted to keep it anonymous. You have an anonymize procedure within Modeler, but perhaps an even safer way to do that is to use something like SimFit, and it will create simulated versions of that data. But here you can see it's actually taking account of the distributions. So we've got normal distribution here, a widal distribution, a log normal distribution. It's tried to fit it appropriately. It's showing us the correlations between the fields, etc., etc. So this is very powerful because here it's created simulated data for us. Okay, simulated data. This is entirely fictional data, but it's been based on a fitting that we've done of the sales data. But we can take this even further and use SimEval here to do what-if analysis. So I'm just going to jump to an example where we show this, and I've got a specific video that looks at this on our website, which is the what-if analysis video. But let's just have a quick look at the SimEval. Okay, so this is where the simulation nodes really come into their own when you use all three together. We've got some data here, and it refers to sales data. I'll just give you a quick preview of it. So each row represents a different store. We've got an advertising budget, we've got consumer confidence index, we've got agents, traffic, and we've got sales value. We really want to predict how many sales or what the sales value we would expect to achieve based upon things like our advertising budget and the number of agents we have available. So we build a model that predicts that outcome. and it's reasonably accurate. It's about 70% accurate. We don't need to worry about that too much now. But what happens if I actually simulate this data to perform some what-if analysis? If I run that, it creates a copy of the same data that we saw earlier on, but this time it's simulated. So we hit preview. Here's our simulated data of advertising, consumer confidence index, etc., etc. Each row represents a sort of virtual store, if you like. And what we can then do is we can score that simulated data using our model that we built earlier on. So it will actually estimate, how many sales we would expect to make. But what we really want to do is we want to play around with 3 different advertising budget values and see what the effect is on our estimated sales if we use different advertising budgets. So to do so, if I go back into this SimGen source node here, I can go into the distribution here and say, okay, well, I don't want to use the simulated fit distribution. I want to use a set of fixed parameters. So I go in here and say fixed parameters, and I'm going to give it 3 different values. I'm going to give it a value of 60,000, a value of 70,000, and a value of 80,000. And if I do that, click OK, then I've got this fixed value here. I can go into advanced options, and I can create a little iteration field called advertising budget. Click OK and connect that up to my simulation evaluation. Here it is. It's going to use advertising budget. It's going to look at the estimated sales, and if I hit run at that point, it then scores the data, the simulated data, if you like, and it shows me what range of values I can expect to get from my 3 different advertising budgets of 60,000, 70,000 and 80,000 respectively. So I can slide these up and down. If I use this bar here, and let's go for about the median value here. Let's go around about the center of this distribution here, and I can say that, well, I've got let's see, I've got a 34% chance of getting more than $7.6 million using the first advertising budget, but 42% chance of achieving it in the second advertising budget, and nearly 51% chance of achieving it using the third advertising budget. So this ability to play around with these 3 different scenarios that we've created here and see what the effect is of sales is really driven by the fact that we can simulate the data and we can pass through different parameter values to perform what-if analysis. It's one of the things that makes simulation so powerful. Okay, so number 6 on the list is the Reclassify node. And it's a very well-established node used widely within SPSS Modeler by all sorts of different users at different levels. But I don't think people really appreciate just how good it is at cleaning data when it's got messy categories. It's just really powerful at that. So let's have a look at how that works. Again, I'm using the simulation generation node here simply to create some data for me to play with, but it's a very typical situation. This is a data set that only has 2 variables in it. One is the ID field, and the other is a field which should be dichotomous. It should be a binary field which indicates which city the respondent's in. But as is typical with a lot of data sets, there are issues with regard to the data entry, and as a result of that we're not getting just 2 values coming out. So if we look at city here, you'll see exactly what's happening. And here we have, as you can see, if I sort it by count, you can see that we actually have London and Birmingham, but we have a lot of spelling mistakes and categories which should be classified as either London or Birmingham, but were actually given other descriptions or misspelled. So the Reclassify node is just really good at dealing with that sort of situation, and it's very good at dealing with situations where you have many string categories that need to be simplified very quickly. And we'll have a look at how it actually does that. If I go to field operations here and call up Reclassify and connect to it, if I go to edit here, I'll call up, ask it to find this field city, and one of the things it can do is if I click the value here, get, it goes and gets the values of the field. That has to, the data has to be instantiated within the source node, but what you can see is it's actually grabbing the values within the data. So I could give these new values. I could type north or south or something like that, or I could just type in London or Birmingham. And the lovely thing about it is that you don't have to type it every single time, because once you've typed it in, it remembers that that has been entered, and you can just cherry pick it from a list. So here we have Birmingham's been remembered in there. Now if I come to London, I can again cherry pick that from the list. There's London and Birmingham just been pulled across here, and it's just a very fast way for me to go through this and to clean these up. Now of course there are different bits of ways in which I could do this using code, but if you imagine situations where you have lots and lots of different values, and you really just want to collapse them all together into a much smaller set, this is a really fast way to do that. So that's one of the reasons we like the Reclassify node. I can either overwrite the existing field or create a new field. Let's overwrite the existing field, click OK, and then we'll just connect the city chart back up to the Reclassify node and run that again. And when we run that, we can see that we only get two cases coming out here, Birmingham, London, so it's cleaned that data up very nicely for us. So our final example takes us to the use of the split role within the type node, and this is just a really powerful little trick that we can play when we're building models and we want to create models for different groups within the data set. So in our final example here, we're just going to illustrate the usage of the split role by starting off by building a simple decision tree using a C5 algorithm. Just to introduce you to the data, first of all, this is a data set called Home Goods, and it's made up of 14 fields, one of which is the card ID, the customer ID, if you like, the loyalty card. And then we have a number of flag fields indicating which products they have purchased within the past 12 months. You know, what areas they've bought in. We've got an age group field here, which is very important, and we've got a target field, which is whether or not they redeemed a voucher, whether or not they took up an offer when it was made to them. And of course, if we want to build a model against that, we could just use any number of different classification models. We just got a C5 model here for illustration purposes, and we're not doing anything like a training or testing here. We're just going to build a simple exploratory model. If I run that, of course, it goes and analyzes the data, it evaluates each of the fields, and it builds a model as is denoted by the nugget here. And if we look inside the model, we can see initially what the predictor importance shows is that, you know, there's some really important variables here. One of the most important right away is gardener outdoor, followed by age group. Age group is really important here with regard to whether or not people redeem this voucher or not. Let's assume that we're finding that, you know, age group is actually really important, and for whatever reason we want to build a model for each age group individually. Perhaps they represent different populations, perhaps they represent different, very distinct markets or market segments. Perhaps we're finding that certain groups or certain age groups the model doesn't perform very well on, and in others it seems to perform very well on. It could be that we take the approach of splitting the model up by age group. Now, how would we go about doing that? Well, if I right click here onto the source node again and click on edit, and if I go to the types tab here, you notice that age group is an input into the model. If I click down here and role, something which people don't notice very often here is this role called split. If I click split here and then click OK and then rerun that procedure, what we'll find is it doesn't just build one model, it builds separate models for each individual age group with separate degrees of accuracy, of course, with each age group. And we can see it's denoted by this little symbol that's appeared next to the nugget. In fact, if we look inside the nugget, we can see that we have an overall accuracy rating here, which is showing us how accurate, and we have in fact 5 different models here. We have one for the people aged 56 and over, for 25 to 35, under 25s, etc., etc. And here are the very separate models. We could pick one here, this one here, let's say 79% accurate, double click on it, look inside it and see it as a decision tree, just as we could if it was a standard model, but in fact it's a separate model in and of itself. And we could go and generate and pick that model out and say, okay, we'll generate that model to palette. It will then pull that model out, and that model will relate only to that particular age group, as we can see here it's shown in the annotations. It's shown in the model the model name here as relating to the B group 25 to 35. And it might be, for example, one of the uses of this is if we find that a particular group we have a very poor fit on, we might then use a separate algorithm. It's a nice way for us to identify where the model is struggling, or whether or not there are actually very distinct populations within the data set that maybe need to be treated separately. So that is the split rule.